we're going to be looking at, the topic is going to be rational exponents. By the way, the word rational, no matter how you look at it, always means fractional or fraction. So when we talk about a rational exponent, we're talking about a fractional exponent. A fractional exponent. And so we need a definition. If I look at a to the 1 divided by n, and what you want to notice is that the exponent is a fraction. It's equivalent to saying the nth root of a to the 1. When I look at a fractional exponent, the numerator is the power on the radicand, and the denominator is the index on the radical. So I look at the issue of 25 to the 1/2 power. This is really the square, there's the radical. Because it's a fractional power, a radical is involved. The denominator, this is the index, so it has an index of 2. The numerator is the power, so it's 25 to the 1 power. So if I look at the square root of 25, it's really 25 to the 1/2 power. 25 has an exponent of 1, the index is 2. And what is then, we're looking at square root, the square root of 25 is 5. Negative 64 to the 1/3 power. Now, because it's a fraction, it's a radical. The denominator is the index, so it has an index of 3. And then I'm taking a set of parentheses. By the way, I don't care what's in the parentheses at this point. It's the set of parentheses to the 1 power. What's in the set of parentheses is a negative 64. And that's just cube root. Cube root of a negative 64 is negative 4. X to the 1/5 power. Well, because it's a fraction, it's a radical. The denominator is the index on the radical. The numerator of that fraction is the power. So it's the 5th root of x to the 1. So the denominator is always the index. The numerator is always the power. 81 to the 12th power, well, that says, it's got a set of parentheses. It's the set of parentheses to the 1 power. And the denominator is 4, so it's the 4th root. What's in the parentheses is 81x to the 12th. So I'm taking the 4th root of 81. What's the 4th root of 81?
3x.
3. And the 4th root of x to the 12th is x to the cube. Yeah. Fractional exponents. Not much fun.
So on the x, the third one,
Mhm.
you just leave it like that?
Yeah, because I don't know what x is, so it really can't be simplified any further. Now here we go. Now this is what's really kind of interesting. Well, maybe only to me, but it's kind of interesting. Is that suppose I have a to the m divided by n. Now remember, if I'm looking at a to the m divided by n is the index, and m is the power. So a to the m divided by n, this is the way we're kind of used to seeing it. This says this is the nth root of a to the m power. That's kind of the way we're used to seeing it. That the denominator is the index and the numerator is the power. Power, and you have an index. Now this is what's so interesting about this, and you just kind of learn to work with it, is that if I have m divided by n, because it is a number, I can rewrite this as m over 1 times n, or 1 over n. Because m times 1 is m, and 1 times n is n. The commutative property of our number system says you can actually reverse this. This is the same as 1 over n times m over 1. This one says power then root. This one says root then power.
The one that you just wrote root next to?
Yeah.
What is that, a 1?
That's a 1 because I started to write an n, so that's a 1. And I don't have my white tape, so. Well, I do have my white tape, I just didn't get out. Now, what's that going to mean to you? Well, anytime I see denominators, to me, I translate immediately into a radical. I don't care what the numerator is, because the numerator is a power, but the denominator is a radical. If I look at negative 27, something raised to the 2/3 power, I'm going to be taking the cube root. Something raised to the 3/4 power, the denominator is 4. I'm taking the 4th root. Something raised to the 3/2 power, the denominator is 2. I'm taking a square root. The way we've been working our problems is this. We would say the denominator is the index, and then I would have 9 cubed. Now, I don't know about you, I don't think I want to cube 9. Cubing 9 is going to be a very big number, then I'm going to have to take the square root of it. Then I've got problems, because my little puny brain can't handle it. This would say power first, then root. Power first, then root. But it says, well, you know, you can root then power because of the commutative property of our number system. I could actually write it this way instead. Root first, then power. So that when I knew this was a square root, is 9a squared? Yeah, so I could take the square root of 9, which is 3, then that gets raised to the 3rd power, which then becomes 27. I can handle that, but give me 9 cubed, which is a very big number, then I'm going to have to take the square root of that thing. It's just too big a number for my mind to grasp. I'm not used to numbers that big. Now, what this says is this is where you have to be very careful. The one thing you guys are going to have to learn, by the way, the thing that killed you on this last test, of course, many of you, and I already told you it was going to happen, is that you reduced across additions and subtractions. And on one of the problems, you can get the right answer, but the wrong way. Because you basically canceled across a subtraction. And you accidentally got the right answer. I make one little change, you get the wrong answer. So, but this says negative 1 times 81 to the 3/4 power, which is negative 1 times, now I could write this as the 4th root of 81 cubed. But is 81 a perfect 4th? Yes, take a look down the powers table. Remember our powers table. I'm looking at something to the fourth power. Is 81 in that list? Yes. And then if I come across, it's 3. So it's 3 to the fourth power is 81. So 81's a perfect fourth. So that says I'm going to root it first, and then I'm going to power it. So I can power it, then root it, or root it, then power it. By the way, most of the time we work with it this way because it's easier. In other words, root it first, then power. Well, this is the opposite of the fourth root of 81 we said was 3. That we're going to cube, which is the opposite of 27, which is, of course, a negative 27. Now, I chose ones again that were similar in nature. Notice, oh bless you. Notice that the minus is on the outside. And here this says, I look on the inside of the parentheses and it's a negative 27. Is 27 a perfect cube? Because this 3 says I'm taking a cube root.
Yes.
Yes. So this is then going to be root it at that set of parentheses, and once you've done that, you're going to square it. So you're going to put a negative 27 in the set of parentheses, and then you're going to square that result. And what's the square root of negative 27? Negative 3, and then negative 3 squared is 9. Root it, then power it. That's the way we work with it most of the time.